How's it going? How's
It
it going,
goes, it
Johnny?
goes.
Hey,
Whoa,
Johnny.
what's going on, man? What's that? What's all that? What's all this?
What's all this? This is just, me being. I'm a graduate student right now. You have to have a beard when you're a graduate student. That's the law.
Wow, it hasn't been that long since I've seen you. I haven't seen all this in years.
And he's
Well,
just got back from being
this is
shipwrecked.
COVID. This is just COVID stuff.
Yeah, it's a strange side effect on some people. Makes you look shipwrecked.
Yeah, this is the vaccine after effects for me.
Yeah, we are live.
I'm auditioning for Castaway too.
Yeah,
Oh, right, yeah.
as the ball football that he becomes friends with. I think
Yeah.
you'll get it,
Right.
mate. I think you'll
Thanks,
get
I appreciate all the support. Okay.
We
is
cannot
Matt-
hear you. Yeah.
Matt talking? Because I see his mouth
I don't know.
moving.
Yeah.
Matt's.
Hey, Matt, you're muted. Matt, you what? He was. So welcome to Go Time, everyone.
Okay, my. He's back.
You were muted.
Yeah, I think when I tried to record my audio, it didn't let me. So, this is, I may not be able to do that. I'll just do a quick comment.
So we don't have to record locally anymore, right? This is that's the old way of doing things, right?
We do it as a backup still, just while this tech is fresh.
Okay. All right. Let me set
If
that
that's
up.
okay.
So should we be hitting record then?
Let's hit record and we'll do a clap, but we may not need to in the future. We may also be live on YouTube and everywhere too.
You want to confirm that?
Level with you. I don't know what I'm doing. I'm
Johnny,
now like
you look great. What's your problem? You always look great.
how to make mistakes in Go. Save. Right.
Higher mark.
Yeah. We'll get into that. Don't worry. Don't worry. Right. I'm gonna just literally go and check the live feed in the browser. Yeah, we're on there, so that's embarrassing. Hello, everyone. The podcast hasn't started until we do the proper intro and stuff, so this is fine. This is a pre-show. It's the pre-show. Everyone gets as a bonus the bit that we cut out because it's nonsense, but everyone gets it as a bonus. It's free, so I think that's fine. Yes, we are live. I've just been told. Brilliant. Okay. Anything you want to get off your chest before we start the podcast?
About 15 pounds. Thank you very much. I'll be here all week.
Great.
Nice.
Good stuff. No, it really is classic humor, and that's why we have Bates on.
I thought it was because you couldn't find a fourth.
Okay, I'm gonna do the intro music. Sorry, I'm working at the same time as banter, and it's tricky. Teiva, have you met Johnny and Mark before, by the way?
No.
Johnny looks frozen.
didn't.
Teiva, how do you pronounce your name?
It's Teiva. That's good enough. Yeah.
Teiva, okay. Well, nice to meet you. Where are you from?
I'm from Paris.
Paris.
Yeah. Nice to meet you guys.
The last one in Las Vegas.
No, Texas.
Great hotel. Oh, is there one in
sure
Texas?
Well, there's Paris, Texas. I assume that's
Ah.
the city he's from.
Yeah, probably.
Yeah, you can hear from my accent, right? That I'm from Texas.
My wife is English, and she's lived here for 20 years. How long we've been married? And occasionally people say to her, "Oh, on the phone, where are you from?" And she'll say, "Oh, where are you based?" And so we're based in Boston. And she'll go, "Oh, you can tell by your accent."
Oh no, that's so embarrassing.
No.
That's embarrassing.
No, not
Yeah.
even close.
I was in Utah once, and someone said, "Oh, where's your accent from?" And she said, "Is it back east?" And I was like, "Yeah, I suppose so."
Pretty far back east.
Yeah, so I don't know. I think who knows? But there you go. See, we've all got different accents, haven't we? It's good. Right, I'm going to do the music, and we're going to do it. We're going to start the podcast, and we're going to be professional because we're a bit late. So,
I was here first. I was ready.
okay,
Matt's fault.
here comes the music. Oh yeah, any minute now. Oh, hang on.
I like the new tune.
No, we were live. Hang on. So here we go.
Let's do it. It's go time.
Hello and welcome to Go Time. I'm Matt Ryer, and today we're talking about how to make mistakes in Go. Why would you want to make mistakes? Well, I'm glad you asked. Tell us then. Well, all right, I will if you don't interrupt, because I will get on with it. Right. So we all make mistakes, and they can be a great way to learn. So that's why we're doing this episode. We're going to hear about some common mistakes that are made, or if you're a brilliant programmer and you want to make more mistakes, so that you fit in better, this is the episode for you. We're joined by the author of Manning Books' 100 Go Mistakes and How to Avoid Them, Teiva. Hello, Teiva. Welcome.
Hey guys, thanks a lot for inviting me. I'm a big fan of the podcast. Yeah.
Oh, then you can stay. We're also joined by regular co-host Johnny Borsico, isn't it? Hello, Johnny.
Yes, it is, isn't it? Hello.
Hello.
Wow, this whole show's turning into a mistake. Can we start over?
No, we can't. It's live. It's recorded live. That other voice you heard, and this may be my mistake, but we've invited Mark Bates back. Hello, Mark. Welcome.
Hello. I don't think you can talk about making mistakes and Go without me being president.
Yeah.
President or president?
President
Either
of
one.
mistakes.
Maybe both.
Yeah.
Maybe both. I'm really good at it.
Yeah, exactly. And that's
really,
it.
really good at it. Matter of fact, 99 of TV's examples are from my repos, which is kind of nice. I feel very proud of that.
Source material.
Great. Well, let's dig in. Teiva, maybe you could just kind of tell us about yourself first. You're an engineer at Beats, right?
Yeah, indeed. Software engineer in a company called Bit. You can visit it on thebit.co. We are in the ride-hailing domain. And by the way, just the small part at the beginning, we are recruiting people and we are doing a lot of Go, a lot of cool stuff. So if you want to take a look at it, please do.
Brilliant. Okay. Yeah. No, feel free to, if you want to plug something, use the platform to plug something, feel free. Don't have to ask in advance. No problem.
Bitbar.
Changed its name now,
Bars,
Johnny.
that
Come
was-
on. I want to also do a quick shout out to Lagos Gophers, which is a Go community in Nigeria. We're doing a regular section, shout ats, where we shout at, because that's what Johnny
So
said last week.
do we just yell at them then?
Yeah.
Is that what we do? That seems awfully rude.
Hey, Lagos! Nice one! So if you're in the area, in Nigeria, then, head over to it. Okay, great. Right, so mistakes. Let's see. Teiva, I asked you to pick some of your favorite mistakes that we could then talk about. So maybe you could pick, we can go for the first one and tell us what was the first mistake you picked?
The first one I picked was related to nil receivers, because I believe it's a very common one. Many of us have already experienced it, and if you don't, at least I hope that it will prevent you from doing it, right? So it's a mistake that I have already seen on a project I was working on. And basically, it was something related to returning a nil receiver. So let's take here as an example. I have a concrete example where we can say, I am going to implement a validate function, for example, right? That validates an HTTP request or something like this, okay? And we don't want to return only the first error we met, right? We would like, for example, to convey that the validation error, convey multiple errors, right? So there are different school of thoughts here, and one of them being, for example, to either slice of errors or just return a custom error type, right? And here we will take the example of returning a custom error type. So we can create, for example, a custom struct called multi-error, let's say, that can contain some different fields and everything. And more importantly, at some point, it contains a slice of errors, right, that we want to kind of mutate throughout the errors. So we take this multi-error struct, we make it implementing the error interface, and it's a pointer receiver because the slice needs to be mutated. So in our validate function, what one guy could do in that case is to say, first, I'm going to create a variable called result. Okay, it's going to be a pointer to multi-error. So I write var result star multi-error, right? And by default, result is going to be assigned to nil, as the zero value of a pointer is nil, right?
Yeah.
So let's say that we implement the whole function, we do the sanity checks, and if there is an error, we mutate result to append a new error. And eventually, in the end of the function, we say, I am going to return the result variable, right? So in the end, result can be either nil, if we face no errors, or it can be a pointer referencing a multi-error instance, right? So let's now say that we implement the consumer side, we called our validation function, and we check whether the error is nil or not, right? And here, surprise, the error is never nil, actually. Even when we faced no errors, the error itself that we return is never nil. So what happened in that case? We have said that eventually we were returning the result variable, right? So if there is no error, actually what we are going to return is a nil receiver, not a nil value directly. And as the return type was an interface, because we return an error interface, right? We didn't return a nil value here. We return an interface implemented by a nil receiver, which is actually different from nil. And that's why the check on the consumer is never nil. And just for information, why do we have this? It's because in Go, a nil receiver is allowed, which might sound a bit odd at first, but it's actually allowed. And the reason is because a method in Go, it's just some kind of syntactic sugar, just like if the receiver was actually the first argument of a function. And it's actually allowed to pass nil arguments for pointers, right? So a nil receiver is completely allowed. And if we want to fix it in that very case, instead of possibly returning a nil receiver, we should return a nil value directly. So eventually in the end, we could do if result equals to nil, return nil instead of returning result, right? And it's actually the same on the consumer side. I mean, on the other side, if a function accepts an interface and we pass to it a nil receiver, not a nil value, the variable assigned to this interface won't be nil. So just as a small conclusion here, when a function accepts or return an interface and that we pass or return a nil receiver, the variable assigned to this interface will never be nil. And in general, actually, having a nil receiver is probably something we never want in Go, and it means a probable bug, so it should be avoided.
Oh, yeah. So that's such an interesting one. How common is this? Because, first of all, if that happened to you, you'd be very surprised, I think, by that. Johnny, have you ever run into this issue?
Perhaps it's my general approach. I tend not to have custom error types that basically themselves contain sort of multiple errors, kind of like the example Teiva has just sort of illustrated. I tend to prefer a slice of errors over a custom type containing multiple errors, right? So I haven't run across this particular issue as laid out, but I can absolutely see myself easily stepping on that landmine, as explained, because it would be a natural thing. I wouldn't be thinking, nil a value versus a nil, that's supposed to point to another type that just happens to be nil, right? So I'm not sort of slicing it that thinly, I guess.
Yeah, I've written code that allowed for methods to be called on the nil version of something, and it was just a kind of, usually it's a no op or some default behavior. But is that too magic, do you think, these days for Go?
Yeah.
Mark? Yeah.
I think so, yeah. I think that's definitely way too magic. I agree with Johnny. I'm well aware of this problem. You know, we talk about it when we're teaching at Gopher Guides. But it's not something like Johnny. I think the way I write my code, I've never hit this particular error, and I almost never use custom error types. When I do, I use a slice of errors, like Johnny kind of talked about. But I don't know. I kind of write my code so that I never hit that. Francesc did a really good, I think it was a GopherCon talk about when nil isn't nil on this very same subject. So it does come up. It's a really good talk, obviously. It does happen all the time to people. It's a super easy, very easy way to like find a bug in your code that will take you 3-4 hours easy to track down.
So I'm curious, is
Like-
there a so what is the antidote? What is the advice that you present in your book, TV? Is it to avoid these kinds of situations, or is there a pattern or an approach to where
Return
you
an
can still use that
explicit
custom
nil?
type? That's one way, yeah.
Well, in that specific case, of course, the solution would be to return nil instead of a pointer receiver. But in general, I mean, okay, we discussed about returning an error and say, okay, perhaps I'm not going to create a custom error type here, but we may still have the case where we return an interface. I mean, in general, okay, in Go, we tend to say we shouldn't return interface, right? We tend to take rather the approach to say I'm going to accept abstractions, so accept interfaces, and rather return concrete types, right? Kind of be liberal with what we accept, and we don't want to force our function to force abstractions, right? But I believe that it's not a hard rule because, and sometimes even you can see from the standard library directly, some functions returning directly an io.reader or io.writer directly instead of a type itself, of a struct, right? So I believe that we may still face the case where we have at some point to return an interface. And yeah, in that case, we still have it to bear in mind that, nil isn't exactly the same thing as a nil receiver. So it's still something I believe that we can face.
Yeah, and why do you think this happened? Is this just something that emerged? Do you think this was a known thing when they were designing the language?
Well, I believe it happened again because it's in method in Go are particular animal. There are just some syntactic sugar, as I said. So, yeah, but I don't have more insights.
Yeah,
on
I
this
don't
one.
think it wasn't a concrete decision to allow or to have it do that. It was just more a matter of it fell out of the type system that way.
Yeah,
Consequence,
That from my understanding of the issue is just that it was something they obviously would have loved to have avoided because it is a bug, obviously, that hits people in a weird bug. But it was just more it fell out of the type system and it wasn't necessarily designed into it.
Yeah, I never thought I'd say this, Mark, but you should be a little bit louder. Move a little closer to the mic.
Should be a
please.
little. I don't know why you don't think I'm loud. But,
I don't know. It's just what I'm hearing.
well, maybe turn yourself up. You ever think of that?
Okay. I don't think that solves the problem. I think that makes it worse, but that's fine.
Here we go.
I've got a common
Well-
I've got a common mistake in Go working with Matt Ryer.
And that's from the
I was gonna save that for the unpopular opinions, but I think it's a popular one. So,
Well,
so far, only David Hernandez seems to be able to stick around and hang in there
Multiple times too.
Don't use his name
multiple
in vain.
times. I don't. I love David. God, yeah, he deserves all that he gets for putting up with you.
I love it. I've never had banter happening and insults concurrently for both Johnny and Mark at the same time. Speaking
try.
of concurrency, here's another one. Teiva, you talk about concurrency. Like we feel like Go is a bit famous for concurrency. It's got some great primitives that makes that so much easier to do than previous languages. Should you always strive to use that to make things concurrent, do you think?
Okay, that's a nice transition.
Yeah,
Thanks for that.
I've been professional.
I don't think I understand the question.
Is concurrency always faster?
Yeah.
That's the question?
Yeah, that's the question.
No. Next question.
It's not a quiz show, Bates.
Well, it's okay, fine.
but-
Continue
okay,
on
that's
with your
in-
line of questioning. I mean, it was a yes or no question. Is it faster? No, it's
Yes.
not always faster.
Is it a common mistake that people make that people think concurrency is always faster, Teiva? Teiva, you have to speak before Bates gets in, otherwise.
I
Why
keep
do you
seeing
even
the
have
setup.
another
I'm
show?
like, Teiva, jump in.
Okay, well. Okay, cool. Yeah, so I believe definitely it's the case. So yeah, I believe that a common misconception from junior or even mid-level developer is to believe that a concurrent solution should always be faster than a sequential one. Because, well, if we implement a concurrent solution that leverages multiple CPU cores, it should obviously be faster than a sequential implementation, right?
Yeah.
No, that's a false
Wrong.
affirmation. Wrong. No, and I believe actually that it's even more of a belief in Go thanks to Goroutine, as you have said, Matt, because Goroutine compared to threads are great. They are more lightweight. They are faster to spin up. They are faster to context switch and so on. So there shouldn't be like any real reason for concurrent application to be slower than sequential application. But I took here as a concrete example, actually. I took as an example the merge sort algorithm. And just as a quick reminder about what the merge sort algorithm is, if we take, for example, the recursive implementation, we basically get a list of elements as an input. And we will break down repeatedly each sublist into two sublists, into two halves, right? We are going to do it repeatedly. And once we reach sublists of a single element, we go up again and we merge the two sublists in a sorted manner. So for example, a quick example, if we have 2 and 1, for example, we are going to split it into two halves, 2 on one side, 1 on the other side. And as each sublist contains a single element, meaning it's already sorted, then we are going to merge it in a sorted manner. So we will have 1 and 2. So in a nutshell, the merge sort algorithm, we get a slice as an input. We check the length of the slice. If it's bigger than 1, we compute the middle. We apply merge sort on the first half, merge sort on the second half, and then we merge, right? And so the structure, for example, of this algorithm seems like a perfect fit for concurrency, because we could say every time I can handle each half into a specific goroutine. So the first half in one goroutine, the second in another goroutine, and say I will introduce some form of synchronization at some point to wait for both goroutines, right? So if we implement this parallel version of the algorithm, I run it on my local computer with a certain number of elements. And actually, this parallel version is about 10 times slower than the sequential version, right? And despite the fact that the parallel version leverages multiple cores, right? So it's more than 10 times slower. And what is the reason for that, if we think a bit about it? So as we say, the algorithm is about to repeatedly split lists into two sublists, right? So at some point we will have 1024 elements, then 512, then 256, and so on until we reach 8, 4, 2, and 1 elements, right? And now let's try to imagine, in your opinion, like what's the fastest between spinning up two goroutines that will both merge two elements and wait for them, or in the current goroutine, merge two elements, then we'll merge two other elements. And of course, it's going to be the latter here, right? Because it's going to be faster to do it in the current goroutine. And if we think about it, actually, in the merge sort algorithm, the deeper we go, the less efficient it will be to spin up a Go routine. And sure, Go routines are fast, but spinning up a new Go routine, it has a cost because we have to wait for its creation. We have to wait for the internal Go scheduler to execute it. We have also the fact that concurrency introduces some form of synchronization because of mutex or channels or whatever. So everything, it has a cost, right? And here the solution, one possible solution for this algorithm, here, well, the goal is not, of course, to design the most optimal solution for the merge sort algorithm, but discuss about a potential solution. It could be to say, I will define a threshold, and I will apply the parallel algorithm that we just described, but if the number of elements is below a certain threshold, it's simply not worth spinning up new Go routines. So instead, I am going to execute sequentially. And this threshold, so okay, may depend on the machine and everything. So on my side, it was about 2048 elements. And if I run this new hybrid version, let's say, of the parallel algorithm, it's about 40% faster this time compared to the sequential implementation.
Yeah.
And one very last thing to say, I have done the same test in Java actually, where we don't have the principle of coroutines, right? We just have threads here, right? And the threshold actually was higher. It was around 4 times bigger, if I recall correctly, compared to coroutines. So it's kind of interesting because somehow it shows that Go routines are actually somehow more efficient than threads for concurrent workloads because they are, for example, faster to spin up. But as we illustrated with the merge sort algorithm, it's not magic nonetheless. Concurrency isn't always faster, right?
So there you go, and quite an interesting thing. So a couple of things there. One is like when you're sharing data, when you're working on the same data, you have to be safe concurrently. So you have to then lock usually, and things are going to be waiting. So that's always something to consider. And then I guess, Johnny, you benchmark things, don't you? That's how you find out these little things.
Exactly. That was going to be sort of my again, in the same spirit of my previous question, like how do you find out, right, what the right sort of threshold is, right? Other than if you benchmarking, it's doing some profiling work and figuring out, okay, where is the diminishing return? Where is that point?
Yeah. Yeah, that's
it's interesting. We're talking about concurrency, and we talk about what, how sometimes concurrency is not faster, and this whole kind of idea. One of the biggest things I've noticed with newbies and anybody coming to Go, really, from any language, is this, like, let's make everything concurrent because we can. And you're demonstrating very empirically, hey, if you do that in the wrong places, you're actually going to hurt your app. But I see it a lot, not even from the numbers perspective, just from the architecture and the complexity that I see a lot of people introduce into their apps when they just have no need for it. And one of those is channels. They build in a lot of channel usage early on because they think they should, and then you're like, oh, actually, you only use channels like in these 3 occasions. So concurrency in Go, it's what drove us all to Go originally, I think. I know it certainly drove Johnny and I, being Rubyists before this, right? It drove us here, drove everybody else here. But then to sit there and say, hang on, just because we've got concurrency doesn't mean you should always use it.
Yeah.
That's a different thing altogether,
Yeah, I think that's a good point. I was going to say also that the complexity thing, that applies actually across the board to any of these little cool features, particularly if it is like you're doing it for optimizations, you're doing it for performance reasons. In most cases, you're going to make your code more complicated and therefore less maintainable. So you just have to weigh that cost. Maybe it's worth it in your case, and maybe it's not.
I often find when I'm building apps, I start serially, and then because I start in the morning.
Yeah,
and then,
have your cereal.
Yeah.
No, that's good. Yeah.
No, the too many dad jokes. Okay, I'll skip that one. Anyway, that one didn't work. That one's out of the repertoire.
It's not a dad joke. That's a serial killer joke.
There's that too. I start, very serially. Like I'm just gonna start my program, and I'm gonna call my methods and my functions as need be, and I'm gonna find as I'm working and as I'm using this app that I'm struggling all of a sudden here or there. I go in, I benchmark or I profile, and I say, oh, you know what? This bit of code here would really benefit from being concurrent, but not the whole thing, just this section where there's a lot of process, a lot of stuff happening, and we can get a big win there. But I only do that once I know that I'm getting that from the testing and the benchmarking.
Yeah, I think that's great advice. Chris James from the Gophers Slack channel Go Time FM, and by the way,
Long-time listener, first-time caller.
and by the way, please join in the chat. That's where we hang out. Chris has a question for the lads with a Z. Chris says, one of the strengths often touted about Go is that because it's very simple, it's more difficult to make mistakes compared to other general purpose languages. But as we are learning, there's at least 100 mistakes you can make, if not more. Does the panel have any ideas on changes to the language that could or should be made to reduce developer mistakes? And kind of shadowing springs to mind for me on this one. I feel like if
shadowing definitely the magic OK is another one.
Yes.
Those
so
are
tell the boys
talk about it. You kind of get the map. Map returns this random OK, Boolean second variable if you ask for it.
Yeah, option.
Or if you're doing a type assertion, right? If you ask for the second random option value that's there, that's these things I don't even think they're documented. You just kind of know that they're there, and none of us mere mortals can add them. The Go team can add them in like weird places.
Yeah.
Like why isn't type assertion? And that's one of my big ones. Why does that not force you
to check if it's okay
to check
or not?
the okay? Because the alternative is a panic. Like
right.
It just like, and I see that all the time. I see type assertions constantly in the code. Without that okay check, and there's just panics waiting to happen. And if I want to panic, I can panic, even with the okay.
Right.
But I also think panics shouldn't exist, but that's another language change I think that could solve a lot of problems.
And do you think that Go is, that generics is going to be a nice use case for that, instead of having to cast every time that you will have to handle generic set of data or something like this?
In some
Generic.
cases, yeah. But the thing is, if you're dealing with data that comes in from JSON or something, often that's when, because there's sometimes you have generic data, so you don't have structs to demarshal it into. You have maps of string interface, and then if there's an object inside an object, that becomes a map string interface too. So you sort of, in that case, you have to rely on that. So in a way, in some cases, probably not. But I don't know. What were you going to say, Mark? Do you like generics?
What I was going to say is I grew up, my first job, I was writing Java, and we didn't have generics.
Oh, all right.
Then I went to Ruby, and we didn't have generics.
What age is that?
What was that?
No, nothing. How old are you? No, carry on.
I'm old. Old.
No.
My first job out of college was I actually was doing ASP, so I kind of lied. I skipped the whole
classic ASP.
Classic ASP.
Oh, you should see it. Bates' ASP was classic, full of banter in the comments.
It was
funny,
as classic ASP as it could get.
Funny variable names. Wow. Oh, he had a blast. Absolutely
Good
classic.
Good times.
Now I can't even remember what I was talking about. Oh,
Generics.
Generics. Thank you.
Programming.
And I've never worked in a language that has had generics to date. Kind of built in, as we know, as the term generics is known throughout the community. I have, as of yet, run into one area in particular where I'm like, generics would have been perfect there. I've been coding for over 20-something years professionally. So I think I like the idea of what generics can possibly do for the language. I'm also afraid of everything they can do to the language.
Yeah, okay. Well, we're going to find out. We'll find out together. And don't worry if you're scared by generics. Go Time is
Well, because I can see performance problems, right? Because we're just talking about people coming to Go and abusing concurrency.
yeah.
And let's be honest, that's what we were talking about. We were being very nice about it, calling it a mistake, but
Right.
it's abusing the technology, right? And we all did it when we first came. New people come and they do it, and that's the mistake, is we keep abusing it, right?
Yeah.
But I see that mistake about to happen again with generics, and I can see everybody rushing to implement everything in generics, and I can see programs crawling to a halt because everything's super slow, or and like tools that are parsing things and working in all these different ways in Go are now going to be not supported or working incorrectly because of generics, or they need to be able to. I just see a lot of potential mistakes coming down the if we're going to keep using that term, mistakes coming down the pipe here
On the channel.
yeah
I take a more optimistic view.
Thank goodness.
No, I mean, I do see the same dangers Mark sees. I guess I'm choosing to look beyond what happens after the initial, spike in all sort of
but that's going to
the
be
abuse.
the first couple years, and
Right, right.
those couple years are going to stick with us for 5 or 10 years.
Yeah, I mean, there is some
Still
of that.
optimistic, Johnny? Still feeling optimistic?
No, I'm no. I'm
Climate change,
really-
Johnny. I mean,
Look, the way things are going, we won't be around maybe to see the change.
that's
after
a
the
good
spike.
point. I
You know,
shouldn't
so
worry about generics because climate change is going to take care of the problem.
It's gonna take care of it.
I'm still worrying about modules. I don't have time to worry about generics.
Wasn't there an episode on that last time?
Yeah.
I think we hit that, right? Yeah.
Yeah, they don't let me on those episodes anymore.
Johnny, are there other kind of common mistakes that you've seen?
Well, I can give you one from personal experience,
yes,
which
please.
actually dovetails quite nicely with the very thing we were just talking about with the sort of the abuse of concurrency, right? So when I first came to Go, and my previous language before that was Ruby, and basically I was like, oh, this is so easy to do concurrent stuff, right? So I started sprinkling it on everything, right? And I was like, "Ooh, channels. How do I use?" You don't need to, for those who don't know, you don't have to use channels to use Go concurrency, right? They're a communication medium, right? It's a synchronization medium, right? So you can have simpler mechanisms like a wait group or things like that. So you don't have to use.
In all fairness, I don't mean to interrupt, Johnny, but I'm going to.
Cool. Well, go right ahead.
Early in the days of concurrency, we only had channels. We didn't have a lot of the other primitives for
True.
controlling things like wait groups, air groups,
Those came after,
context,
yeah.
context,
Sync
stuff like
package,
that.
yep.
So all of the early documentation and all those early blog posts and videos, everybody's like, you got to use channels to start and stop Go routines and keep them in sync and protect mutexes and whatever. But anyway,
Who's that
Go
voice
on.
you're doing?
you like that?
Yeah.
That's
you
his
do that
grumpy
for-
old man voice.
Yeah.
That my normal voice is my grumpy old man voice.
Yeah. No.
That was my grumpier old man voice.
Grumpy.
As he climbs in age, everybody.
I'm gonna sound like in 5 years. Go on.
Right. No, but so the personal experience is one where basically, I was actually in charge of building this sort of a batch sort of job thing where I'm communicating with some remote endpoint and making multiple API requests, and for some reason there was no batch sort of API endpoint to hit to give you a bunch of stuff. You kind of had to make singular requests, if you will. So I'm like, hey, Go routines are great for that, right? So I basically, I do testing, not always test-driven development, but I always test my code. There's a difference. We'll get into that later. I write my mocks. I have my stubs locally and everything else. I'm sort of faking the API response, and I'm throwing Go routines at it. Everything's going perfectly, right? Everything just works, right? And then I put the thing into production, and then all of a sudden, right, those hundreds of Go routines, perhaps even thousands of Go routines that I was launching to hit my during testing, this mock endpoint, now is actually hitting the real thing. I start seeing a bunch of 429s in HTTP status code in my logs. I'm like, what's going on, right? For those who don't know HTTP status code, 429 means basically you're making too many requests. The server on the other side is saying, no mas, I'm not going to bother responding to you because you're simply abusing this API, basically.
Oh, your code was too good.
Well, perhaps not sensibly written, right? Again,
So what did you do? Put a sleep in before each one? Random sleep.
That fixes it, doesn't it? Doesn't that solve the problem?
fixes it. Yeah, it was one of those things where I'm like, yes, perhaps too much concurrency, right, will bite you, right? So you have to factor in, which is something I also teach when I'm talking about Go concurrency. You have to factor in the constraints of your system. Like Go is not going to be your bottleneck. The language is not going to be the thing that makes your stuff doesn't go slow. Like your databases are going to be bottlenecks. The network is going to be your bottleneck, right? The third party endpoint you have to talk to, right, over the wire, that's going to be your bottleneck, right? Not the language. So factor in the constraints that you have to work with. What problem are you solving? What are the constraints that exist within that problem domain? The language itself, that's not your problem.
That's we teach the same thing at Go for Guides. And that's one of the nice things about Go, right? Is for 98 or even higher percent of us, the language has our back in terms of performance and just making sure we're not shooting ourselves too badly in the foot. And it's the database, it's the network, it's the file system, right? Those are the things that are going to make your app just crawl. It's not going to be that little bit of business logic you have in validating a struct to make sure that there's an email address and a first name, like those, like all that sort of stuff. It's the network calls, it's your database, which is just a network call unto itself, and that's all a database is. Or you're calling the file system, if it's which is just even worse than the network half the time, right? So yeah, those are all real issues that I think people just kind of get in their heads, and they think the language, they need to fix it in the language and not kind of looking at what they're programming and what they're coding and say, okay, let me focus on that and find those performance issues later.
Yeah.
When they become that problem. This is, I think, the second time we've come back to that kind of concept, isn't it?
Yeah, but it's an important one. It comes up a lot, and it's worth bearing in mind as you're underway, as you're writing code. It is worth bearing in mind. Yeah. So, Teiva, there's also another one about time after. This is from the book. Time after, you can possibly have a memory leak.
Yeah. So, well, memory, not really memory leak per se, but having a peak of resource consumption in some specific cases, let's say. So, just as a reminder, time.after that accept as an input a time.duration, right? And it returns a channel of time.time, right? And it waits for the duration to elapse and then sends the current time on the return channel. And most of the time, it's also used in concurrent applications, let's say, because of the handy channel. Otherwise, if we just want to wait some time in the current Go routine, we can just use time.sleep, right? So let's say that, let's imagine we want to implement a kind of smart consumer, I don't know how to call it, that will keep receiving messages from a channel, right? But let's say if we don't receive any messages for, let's say, 1 hour, we also want to log a message, right? To log an alert, for example, or something like this.
Yeah.
And one way we could implement it is using time.after in this case, and we could say, I will have a for loop with with a select inside and 2 cases. And in the first case, I am going to receive messages from the channel and then call a function, do whatever with this the message we have received, right? And in the second case, we are going to receive on the channel that is returned by time.after to log the alert. I haven't received a message since 1 hour, right?
Yeah.
So in that case, let's say we just deploy our application, we keep receiving messages, that's great, but we notice that it consumes more and more memory and it seems to steadily increase actually. So what's the reason actually for that? We have to know that in every iteration, Go will actually evaluate time.after and it will create a new channel. Yeah. And we may actually expect this channel to be closed in every iteration, but it's not the case. Actually, the resources that are created .after, including the channel itself, they will be released once the timeout expires, right? So in the worst case scenario where we keep receiving a high volume of messages, we will keep looping, we will repeatedly call time.after in each iteration, and it will keep creating resources until the duration, in our case 1 hour, elapses, basically.
Yeah. Now I have definitely made this mistake, doing exactly
Hang on,
that.
I'll be right back. I gotta
Yeah.
go fix something.
Yeah. Yeah. I mean, and so the answer must be to create the channel outside. What's the answer? How do you avoid that?
There are different solutions. One of them could be to say I can use context.with timeout, but it's not perfect nonetheless, because it would mean that in every iteration I have to call .context.with timeout, and it's going to create a channel. It's not lightweight. Here, the most appropriate solution could be to use within the time package the timer structure.
Yeah.
The timer structure, basically, we can create it with timer.newTimer, where we pass a time duration, and internally it has a channel field that we can access. It's timer.c, and it has also a reset method. And the reset method, that's going to reset basically the duration. So what we could do in our case, we could say, okay, during the, before to loop, I'm going to create this timer. In the second case, I'm going to listen on the timer.c field, which is the channel, right? In every loop iteration, I'm going to call time.reset to reset the duration. And here, it will just reuse the same channel, basically. So it won't have to create a new channel. And so, yeah, that's probably the most appropriate solution here.
So is it possible to use time after in a safe way then, or should we just avoid it altogether?
I believe if we are in the context of a function that keeps being called, be it in a loop, for example, or we can have also the case in an HTTP handler, right? Because in an HTTP handler, if we call time.after and that we keep calling this HTTP handler, we may have the same case, right? So my recommendation here is probably to not use time.after when we are in a context of a function being called repeatedly, right?
Right. Yeah, that's a good one.
Nice.
Yeah, that is a good one.
Very good one. Yeah.
Bates, you were talking earlier about another common gotcha.
I was.
Yes, to do with the API footprint that you export.
And by talking about that earlier, you mean in the private message I sent you this morning?
Yeah,
Completely offline and out of context of this call.
Yeah, that's true. You weren't talking about it earlier on
right.
this podcast. It's just a mistake. It's part of the theme of the show. I'm going to be making lots of mistakes.
I love it. I love it. Yeah.
No, please, John, go on.
So yeah, well, Matt obviously asked us all to submit kind of common mistakes that we see a lot.
Why it's
one of the ones
telling him how we do it. Just do the thing. Don't tell him how we've done it.
Well, it's
Nate,
it's not that big a deal. I don't,
exactly.
The sausage is being made here, right? It's
I
just
know.
a mistake, yeah.
That's the problem, though. I want them to think this show is way more sophisticated than just me texting you while you're having your cereal.
Well, that would be his mistake now, wouldn't it?
Exactly. Anyway, one of the things I see new developers to do a lot is basically export everything.
Right.
Everything starts with a capital letter, and that's it. Like their entire package, all of their types, every field in their type, every method on their types, everything is public. And of course, when you do that, you can't take that back now. You can't, that's it. It's out there as soon as people start hooking into it. And I feel, modules have made this problem a little more complicated in some areas, but it's definitely one of the big issues I see, where people should be starting with everything unexported, and only pushing up those pieces that they need. I think it's a lot to do with just people misunderstanding the way Go does exporting and unexporting, because it's different than every other language I've used. This
Yeah.
whole idea of capitalization to infer
Mm-hmm.
whether it's public or private. I love it now that
Yeah.
like once I got it, I'm like, oh, that's brilliant, because I can look at anything in my system and immediately know whether it's visible or not. Right?
Right.
I'm not scrolling up to look for a private or protected method above it. But at the same point, I think new people come to the language and they see things that are uppercased or whatever, and they think, I'll just uppercase everything because it's a proper word. It's the
Right.
user struct. So therefore, you must be capital U.
So would you say that
Right.
people should just by default use lowercase letters everywhere until you then need to export it for some reason?
Yeah, I mean, you'd have to sell me on why you would want to do it the other way around.
Right. Do I?
You know, I mean, there are definitely types when I open up a package and I go, this type has to be exported.
Because you're thinking about the use of that package.
Yeah,
Because I
so
know what
it's-
the
yeah.
use of this package is, right? But, you know, so I'll say, okay, my user type I need to export because I need other people to use it. But the fields may or may not be fully exported, right?
Yeah.
Like, you know, or the methods might all start as unexported methods until I need one to be promoted. I needed to use it outside the package. And again, it's like, well, do I need that method or do I need something similar to that method? It might be better, well-coded X, Y, and Z or
Yeah.
somewhere else, right?
Mm-hmm.
So,
you know what you just made me think of? It wasn't a deliberate. It wasn't a
I'm glad this
deliberate
is coming out
choice.
of your mind and not mine. Go on.
Yeah, now that I think about it, it wasn't a deliberate choice. It was more of a, I don't know, maybe I'm sort of adopting some of Mark's grumpy old, dude sort of persona. But I was like, my interfaces, right, inside of my packages, I don't export those at all because I don't want the consumer of that package to have a dependency on my own abstractions and my own interfaces, right? So it's almost like I say, well, if you want to create abstractions or whatever it is, if you create your own interface, create a local interface to you, right, for whatever I'm gonna hand over to you. But I don't tend to rather expose my interfaces from my packages. And it wasn't deliberate. It just kind of happened.
Oh,
I do expose a decent amount of interfaces, but I also write a lot of local unexported interfaces inside of another function or method sometimes. Just
Right,
so I
inline.
can I just wanted, just inline because I want to check, does it have this method on it? And if so, I want to call it, and I don't need some big interface somewhere else. I can just do it right there in line. And that's one of the nice things about Go is that you can do that sort of thing. But that's an advanced feature, Johnny. That's a feature that I don't know about you, when I teach, I teach a lot of intro to Go at Gopher Guides, and interfaces is one of those things that people really struggle with coming to Go. It surprises me because they're on the surface relatively easy. Like there's not a lot to them. It's a collection of methods. You either implement those methods or you don't, right? But people really struggle with that, and they struggle with the implicit versus explicit declaration of an interface. I'm not impling, this isn't my foo impl of this interface, right? And then they certainly don't realize that you can create inline unexported types and interfaces like inside of a method to make your life even that much more easy right there.
Right.
Yeah, one downside to that technique is you can hide things inside the function. It's not always obvious that, you have to use docs or something to say, if it implements this interface, then it'll have this different behavior. So it is quite an advanced case, I think.
It's very, very much so. I use it mostly in an exception case where I've got an error or something.
Right.
And I want to try to see if I can inspect a bit more information out of this thing.
Yeah.
If I can. Otherwise, if I'm letting people know that I'm supporting these methods via interfaces, then I'll expose those interfaces.
Gotcha. Yeah.
More for the sake of hanging documentation on them. That, just saying like, hey, this method's going to take these 5 interfaces.
Yeah.
So it's a documentation thing versus a required to be passed in thing.
Well, it's that time again. Teiva, hold this bass. Johnny, you're on the drums. Bates, pick up the guitar. It's time for Unpopular Opinion. probably leave. Who's got a meaty unpopular opinion? I said it wrong.
I do. I'll fire the first salvo.
Okay. Okay.
That came out of nowhere. You look surprised.
Yeah, I was surprised.
Yeah, I don't often have unpopular opinions.
I know. Because you're nice. That's what we were saying earlier, Mark, privately.
Well,
Yeah,
text.
that's what we were saying earlier. Yes, we were saying what a nice guy Johnny was.
Yeah.
Yeah, that's it.
Yeah.
Don't you think Mark Bates looks like he's? Don't you think Mark Bates looks like he's just got back from being shipwrecked?
I made fire.
I've been stuck on that island for so long, thinking about generics and stewing away.
I'm like Hurley from Lost. Somehow I gain weight being stranded on a desert island. I'm not quite sure how that happens.
No, you look great though, mate. Really.
Oh, thank you.
My beard's only jealous.
That's your unpopular opinion, I assume.
Yeah. Well, we'll ask.
Then I look good because that is definitely an unpopular opinion in my house.
You definitely would make a good Guess Who character from that game. Guess Who? Like way more interesting.
Fair enough.
Yeah.
Can I opine now?
Please,
Yeah, go
Johnny.
for it.
I'm sorry.
Please help us.
Okay. I have to break this up. Yeah. All right. Yeah, and for those who don't know, this is actually what happens in real life too. Yeah. Hanging out with these guys.
Apart from, I'll be getting a piggyback off Bates by now.
That's true. And there's usually a lot more food involved.
Yeah, and alcohol. Yeah, sadly. Anyways, so my you guys.
Still waiting on you, Johnny.
I know. I'm trying to get it out. Y'all keep making me laugh. All right. So here it is. I think everybody coming to Go should make as many mistakes as possible. 'Cause that's how you learn.
There you go.
That's how
I
you
don't
learn.
think that's an unpopular opinion.
Well, I've never.
I'm gonna disagree with you. I think because I
What?
think the adage of making mistakes is like people know that you're supposed to learn from your mistakes and mistakes are good. So I don't go purposefully make mistakes. I don't know how you'd even do that because they're not mistakes. Then you're just breaking your code because you're like,
Yeah, you must
Johnny
know.
said I should make my code terrible. I should introduce as many bugs as possible if I'm going to become a better Go developer. That's not, I think, what Johnny was trying to say, I hope.
Right.
That really would be an unpopular opinion. Johnny says, do a terrible job at work and you'll become a better Go developer.
Break all the things. No. So here's some nuance. Here's some nuance. So so I don't know about y'all, but when I'm learning something, like maybe on the job, or if I know that at some point somebody's gonna look at whatever it is that I'm trying to do, like I go into this sort of learning paralysis where I just keep learning and learning and learning and reading and watching, just consuming everything I possibly can, so that the first piece of code I write has to be perfect. Right, because I'm so sort of sensitive to the criticism, right? I over time I've sort of learned to sort of feel less of that sort of I guess pain or feeling of inadequacy and whatnot. But like I will spend a ton of time just becoming an expert at something without like actual practical knowledge that actually does make you an expert. So don't be in a learning paralysis sort of mode, right? Like put stuff out there, make mistakes. Talk about it, right? It's okay if you will. I mean, this is the internet. You will find a jerk that says, "Hey, this stuff is crap." That's fine. Brush it off, right? Most people are not like that, right? So don't be paralyzed, right? Just make mistakes in public. Learn in public. That's okay.
And that also extends, like, we should be forgiving as well when we see people making mistakes. Like, when you give that feedback, do that in a way.
Jerk. Yeah, don't be that
exactly.
jerk.
Yeah, do it.
Because we all do it. Johnny, I think you and I have very different coding styles. Because you said like I want to learn something new, and what I'll do is I'll go and I'll find something that says like this is how you get up and started to Hello World, and that's usually where I drop off, and I just start coding and just like start hacking and like throwing things in like, well, that didn't work. What the hell? And like so. I personally, that's the way I code. My, when I'm learning something new anyway, like if it's a brand new tool, a package, a library, some concept I've never done before, I just write code. I can't just read and read and read. I gotta just bang it out until I get to a point where I go, oh, that worked, yay! Now, how do I make that clean and good, and do what I actually want it to do, not just I got it to make a connection and return hi to me. You know, like great. Now let's take this and try to build on that. So
Yeah, you can't really. You learn so much by building the real thing, and this also speaks to like software engineering generally. We want to design it all up front. Sometimes we want to know exactly what it's going to be, so we can do good estimates and things. You learn so much by doing it, so get on and do it. You'll just make so much more ground, and making mistakes in that sense is great, because that really is how you find out what the real thing to do is. Sometimes it's impossible to know up front, isn't it?
I'd say 9 out of 10 times I run tests, they fail.
Yeah.
And I'm okay with that most of the time. There are times when I'm like, why the hell are you feeling? But most of the times, it's like, yeah, okay, I'm still not there yet. I just got to keep, that didn't work. What can I try now?
Yeah.
To get this test to pass. Like, just keep making those mistakes till you find it. And that's
Yeah.
okay.
Yeah, absolutely. Well, speaking of mistakes, Teiva's book, 100 Go Mistakes,
Are you
is...
saying that his book is a mistake?
No, his book's about mistakes.
We
Matt,
treat
you're
our
doing a
guests better than
terrible
that.
job. I think it's a wonderful book, and
Matt,
despite what you say.
Teiva, don't believe what he says.
Yeah,
Yeah.
Teiva, man, Matt's just
Great book,
he's
great
jealous.
work.
Jealous.
Your
That
stuff
was
is not a
rude,
mistake.
right? That was
Jealous.
rude.
His Blueprints book hasn't sold well in years.
Of course it has. It's absolutely full of mistakes.
Yeah, that's why it hasn't sold well in years, mate.
Well, you can find out for yourself by buying my book, and also getting we've got Bates. Let's try this, Bates.
You can go to my torrent site and just download his book for free.
That's how we treat friends. We
I'll
just
put the link I'll put the link up on Twitter after the show.
Oh, good. Thank you for putting it there so nobody will
eventually.
see it. The Bates, pick a number between 34 and 36.
Oh, I hate the way this works. 42.
No, a number between 34 and 36.
I was told there wouldn't be
Maths? It's
Maths?
not really maths, is it? 34
Okay.
and 36. There's only one option,
It's
mate.
35.
Yeah,
okay,
35. Okay, you said it. 35%. We're going to give a 35% discount to anybody that wants to buy Teiva's book using the secret code PODGOTIME21. That's PODGOTIME 21. And we're also going to be giving a free copy away as well, Teiva. This is very nice of you to do this. So if you can tell me, what title did Mark Bates give himself by mistake earlier in this episode? It's the something of mistakes. He gave himself this very grandiose title, as we've come to expect from Mr. Bates. If you can tweet what that is, we'll pick one over the next week. Tweet at GoTimeFM, the answer to that, and we'll send you a secret code, and you can get a full ebook of 100 Go mistakes and how to avoid them. That's good, isn't it?
It is. I like that.
Bates?
I'd read that book.
Yeah. You're going to try and win, aren't you?
I mate. I'm not quite sure what I called myself. Actually, I think I know.
Yeah, you'd have to listen
But
back.
I just didn't think you'd say that on the air, so I'm surprised.
Well, we'll see. Hopefully, it has to make it in. I'm only saying it so it makes it into the podcast episode. And I've made it part of the format. And that's how you do it.
Gotta be.
Teiva, thank you so much for joining us. Absolute pleasure to have you here and learn about mistakes. And good luck with your book. We'll look forward to reading it. Johnny Borsico, always a pleasure. And Mark Bates was also here. Goodbye.
Thank you.
Thank you so much.
And that's it, really. I mean, the song goes on, but there's... come on.
I was about to do the chicken dance. So
Oh, I should have kept it playing. I'm so glad it's a podcast. Thank you
I don't
so
know
much.
why anybody would watch this podcast.
They do. And hello
do,
to
right.
all the...
On the tubes.
Yeah.
I can understand why you'd listen. I don't have any idea why you'd want to watch us.
Because you're hilarious, mate.
I'm awake.
Yeah, there's pros and cons, isn't there?
Yeah.
Okay, brilliant stuff. Thank you again. I mean, this is it. We've done the podcast. That will editors will turn that into something that sounds really professional.
I hope
Believe
so.
it or not.
Right. They'll
That-
just cut
that-
out all the parts Matt was speaking.
You nearly said Mark as well. I love that.
So
You're
it's just
brave.
No,
gonna
I
be
said,
like,
I said Mark and Matt. Yeah.
Oh yeah, yeah,
so it's just gonna be 45 minutes of TV speaking,
yeah.
and that's it.
That's
it.
probably what
Yeah.
people want anyway.
That's honestly, that's probably a much better podcast than what we just did.
Yeah, it's
You just next time, Teiva, you just do it. We'll just be quiet.
more like the audiobook version of your book. You could just read it with your accent. That's the thing. People love accents.
You know, Matt and
delivering.
I could do the audio reading of your book,
with
Say
different
no,
voices.
Say no. Say no.
and we
They know.
do it for a reasonable rate. Well, one of us would take the narrative, and one of us would take the code. You see.
Yeah, yeah.
Mm.
Can you?
So one would be the voice of the code.
Like,
Yeah.
you ever heard Matt do the file path walk?
Rap. Yeah, that was my
Bit.
idea, Mister.
What?
Okay.
Yeah, but
That-
would you read the code in like a Stephen Hawking voice? Because it's kind of fixed width font.
well, who says I'm reading the code? Why can't you? I want to do the narrative.
Okay. Yeah, you've got the sort of bouncy kind of voice.
You got to
that-
keep the people interested. You know?
Yeah, and I'll be just like reading out the code in a boring way.
Yeah.
Yeah.
Exactly.
While having some tea.
See, Steven, we got it all sorted out. You just send us a copy of the book. We'll get it to you in the mail by Tuesday. Today's Tuesday. End of day today. We'll do it by the end of day today. We're that good.
Yeah.
One take without having read the book. We'll just write down.
Yeah.
Mistakes were made.
That would be a mistake.
Many,
and that
many
fits in.
mistakes were made.
It's in.
We'll airdrop you off a zip drive later.
A zip drive. Oh man, a zip drive.
That wasn't actually
no. This is audio. We'll send a mini disc. You know.
Mini
Oh,
disc. I
yeah.
thought about
Yeah.
sending a mini disc. I have a mini disc recorder and player right there. I could easily.
Yeah.
Do you?
Yeah. We all have one. Yeah.
I don't even know what is a mini disc.
You don't have a mini disc player
have a
readily
mini disc
handy?
No?
Yeah, man.
No?
It's like a Walkman with. It's like a Walkman held by a massive Bates.
It's it's look at this. Skybar 9. This is a disc from 2002.
Oh, that's
I've never seen this. Okay.
A recording of a band of mine from September of 2002. So there you go.
Plugging,
it's mini
why is he
disc.
plugging that now?
They're yeah, right. Everybody should go and listen to this bootleg recording of my band that did not do anything back in the early 2000s apart from make this bootleg recording.
Yeah.
Anyway, yeah, they were terribly sounded awful. They were highly compressed
Mm.
too. Yeah, it sounded really bad. Anyway,
Yeah. Good though,
There
old
you
tech.
Yeah. If you have a portable I can send that to you.
Ooh.
You know, with my Toshiba Protege.
are you gonna squirt that to me, or is that
I'm gonna-
Zune squirted?
What can that do,
No.
Johnny?
This is my pocket PC. Yeah, I use it to schedule appointments. Read email. It's kind of like the BlackBerry before they got good. This is This
Is it
my-
Wi-Fi?
Little old school.
No.
How's it
the-
connect?
it will
2G.
support like the older
cellular.
cellular.
I
style,
actually
yeah.
the first job I got out of college, we got bought by Palm, the people who made Palm pilots.
Mm.
So yeah, talk about dating yourself. Yeah, Johnny's got his little stylus out.
I got my little stylus.
There you go.
I can
I
take
used to
notes.
walk around with a Palm 7X because I was doing wireless development for them. The thing was like a brick. It was this big, had a giant rubber antenna to get like the kilobytes of data down, and it was a ridiculous amount of money. It was like $500, $200 a month for like 50 kilobytes of data. Like something ridiculous. It would shoot through
256
triple
megabytes
Oh,
of data.
oh, megabytes.
This is megabytes. Yeah,
Wow.
this is like
Megabytes, yeah.
this is top of the line right there. This is like
That was
this is like massive storage.
Has that still got data on it, Johnny?
I don't know. I hope not.
This is the oldest. This is the oldest of my devices.
Is that 4-track?
This is a 4-track, yeah, cassette 4-track.
Wow.
This is the oldest obscure audio device I have.
This would record audio on. It would split the tape basically would record on one half and the other half at the same time, right? And then
Yeah.
the left track, the right
left,
track.
left, right. Yeah.
Yeah,
so you
wow.
I do have an 8-track over there, but it's a lot heavier and much harder to lift. Like an 8-track
twice as
cassette
heavy.
version.
Yeah.
Yeah, it's twice as big.
What
and twice as
cassette?
heavy.
How did they put the data on that? Just smaller.
I don't know. Ask
Track.
Tascam. I didn't.
I'm gonna ask
You can only
Tascam.
record. You can only record 4 tracks at a time now.
Okay. Yeah.
So
Okay.
and I think it was like you could record.
Bounce.
Yeah, but you could record even tracks
Yeah.
or odd tracks at a time.
Oh, so they did split it then. They must have made it smaller. That makes
Yeah,
sense.
they did, but so the record head could only do the evens because it was so small, or
Yeah.
the odds. Track.
We
Anyway.
we used to
I think we're
record on
getting
a,
way off topic here.
just before we do though. We used to record on a 4-track, and you'd do like 3 tracks and get them right, and then
fourth.
bounce them to the remaining one and clear them. Yeah,
Yeah,
but it,
that's what the Beatles did.
yeah, what got enough for the
It worked-
Beatles?
worked for them. You know,
Exactly.
I mean, they made a career out of it.
Yeah, a lot of people have heard of them.
They've done a couple things.
They got a
I
couple
would
of albums.
recommend the McCartney 321 documentary on Hulu for anybody who's curious. Him and Rick Rubin just listening to Beatles multi-tracks and Wings multi-tracks and stuff. It's phenomenal.
What's your favorite Beatles album, Mark? The best of the Beatles.
The best of the Beatles, yeah.
Yeah, he loves that
That
one.
definitely means yeah. Yes. Aha. Anyway.
You're listening
Sunday.
to
Bloody
This Morning's
Sunday.
Farmer.
Okay, I think we need to go then. It's
I do.
17-1.
Long ago. Thanks,
17-1.
everyone.
Yes, thank you.
Thanks for watching.
Aha.
And thanks, everyone. Lovely to meet you, Teiva. Take care.